Boom. Hello and welcome back to Calculus 1, right? The Tuesday edition at 5:30 or so. The goal for today is to finish chapter 3. We have a very short section first, 310, on derivatives of inverse functions. We have 6 formulas, and we're not going to derive them. Derivations are in the book. They are straightforward using implicit differentiation. You can quickly come up with all of these formulas if you're interested. Generally, one of these derivations would be my question on the honors exam when I teach honors section. So we are focusing on computation in this course. And that boils down to you knowing the formula and then being careful with the chain rule, product rule, or whatever else pops up. So that's that part. So let's, the whole lecture is just me listing the formulas and then using them on few examples, and we're done. That's technically what it is. So let's take a look at formulas. Now, as I said, it's very easy to memorize all 6 of these because you know the first 3, and the other 3 are just minus signs, and everything is the same. So hopefully you've seen that when you did your class prep. But let's go with these formulas. So the derivative of sine inverse x is equal to 1 over the square root of 1 minus x squared. The derivative of tangent inverse of x is 1 over 1 plus x squared. And by the way, these 2 formulas are used most of the time. You will see a lot of these in Calculus 2, of these 2. A lot of these in Calc 2, and a lot of these in differential equations later on. And then we have the derivative of the secant. This one pops up, just a bit here and there, but it's not that frequent as the ones upstairs. So it's 1 over the absolute value of x, and then square root of x squared minus 1. So these are the inverse sine, inverse tangent, and inverse secant. We have the other 3, and the other 3 are the same formulas, and you put minus everywhere. So what is the derivative of inverse cosine of x? It's going to be negative 1 over square root of 1 minus x squared. The derivative of cotangent inverse of x is just negative 1 over 1 plus x squared. So you can see they are the same, except these are negative. And then ddx of cosecant inverse of x, which is going to be negative 1 over absolute value of x, square root of x squared minus 1. These are the basic formulas. Now we do want to So these are the basic formulas, and we do want to just think a little bit about what we are actually going to use, and that is the inverses of composite functions. So what is the derivative of, let's say, tangent inverse of, let's say, 10x. So now you have to use the chain rule, right? So you still get your 1 over 1 plus, and now this is going to be 10x squared. And then you have to follow with chain rule, which is the derivative of the inside, and that's 10. So the total is 10 over 1 plus 100x squared. And that would be the derivative. Now, what this does is it helps you kind of come up with this modified formula, which is a better formula, which says that the derivative of inverse tangent of f of x, right? Because you can have whatever. You don't, right? It's not just x that you worry about. It could be e to the x there. It could be another trig function. It could be nested inverse. It could be ln. It could be anything, right? Polynomial, like I have over here, 10x. So when you have that modification, then you say f prime of x divided by 1 plus f squared. So you will take the argument as is, copy, and then derivative. That's generally what it is. So you take the argument. Remember what the ln derivatives were? You copy the function, and then you write the derivative up. Good evening. Where's my coffee? So that's the ln, right? So the same thing here. You would copy the function as is, and then you will write. So let's take a look at, say, the derivative of secant inverse of square root of x, because we can. So you have the formula at the top of the screen. You have the formula at the top of the screen. You have the problem on the bottom of the screen. Try to put this together in your notes. Don't tempt me. So at this point, it's just plug in, right? Your f of x is root x. So the derivative will go on top, so that's 1 over 2 root x. And then you have the absolute value of root x times the square root of x squared minus 1. And now you simplify. So the 2 root x from the numerator goes down, and you have root x times root x, that's x. So this is now 1 over 2x square root of x minus 1. And that's what it is. You solve some algebra, right? And you're done. So let's do one more problem, because you love this so much. Let's do the tangent line, right? I know how much you love tangent line. Do you? Good. We're still going to do tangent line. So problem 33 in a textbook says tangent line for f of x equals inverse cosine of x squared at the point 1 over root 2 pi over 3. Why, they couldn't give us root 2 over 2 rationalized version? Nah. Whatever. So find the tangent line for function inverse cosine of x squared is inverse cosine of x squared at the point 1 over root 2 pi over 3. Go. Okay, sounds like you guys are done with the tangent line. So what's the tangent line? 21? Okay, no. Anyone else? Let's take a look. So the first order of business is to figure out the derivative. And the derivative for inverse cosine is -1 over, right? But we have to use the function. So it's -1 over square root of x squared, so that's x to the 4th minus 1 times the derivative of the x squared, which is 2x. So the whole thing is -2x over square root of x to the 4th minus 1. 1 minus x to the 4th. So please pay attention over here with the derivative. Each one of these has 1 in the numerator, and that's what f prime would go. So if this is not x but any other function, then its derivative would go there, because it's times, right, for the chain rule, it's times f prime. So now that I have this, I have the derivative. Slope m is the derivative computed at the point x, which is 1 over root 2. So that's going to be -2 times 1 over root 2 divided by the square root of 1 minus 1 over root 2 to the 4th. So now this is -2 over root 2 in the numerator divided by square root of 1 minus, and this is 1/4. Because 1 to the 4th is 1. Root 2 squared is just 2, and then another square, so it's 4. And now we calculate, so this is -2 over root 2 divided by square root of 3/4. So now what's our slope? It's -2 over root 2 divided by root 3 over 2. And when you combine all of this, you get -4 over root 6. -4 over root 6. So now, -4 over root 6, and you have the slope. And you also have a point of 1 over root 2 and pi over 3. So plug everything in the formula. So y equal mx plus b. Y is equal to pi over 3. M is equal to -4 over root 6. And x is equal to 1 over root 2 plus b. So pi over 3 is equal to -4 over root 12, but that can be simplified, plus b. Root 12 is 2 root 3. So this is -4 over 2 root 3 plus b. And these guys now cancel. So you have pi over 3 is equal to -2 over root 3. And I'm going to rationalize this. And I'm rationalizing it because when I get the b alone, it's going to be pi over 3 minus, and then plus, right, because this goes to the other side. And I have 2 root 3 over 3, which is common denominator, so this is pi plus 2 root 3 over 3. And there's my tangent line. So y equals, what's the slope? The slope is, well, I don't like it that it's over root 6. So that should be times root 6 times root 6 to get rid of the, so that's -4 root 6 over 6. X plus pi plus 2 root 3 over 3. So what I'm going to do here is cancel these guys. So I have -2 root 6 over 3 x plus pi plus 2 root 3 over 3. Oh wow, I can kick out 1/3. Nice. So 1/3 times, and then I have negative 2 root 6x plus pi plus 2 root 3. And that's the tangent line. Arithmetic. Arithmetic. And then that's it. I hope you're not disappointed, but that's our section 3.10. So we'll restart the stream for 3.11, my favorite.